interferometry. And interferometry is a technique that allows you to see in much better details any celestial object. With the VLTI, so the interferometry on the VLT, we can observe detail which are 25 times better than what we can do with a single unit telescope on the VLT. And in addition to those 8 telescopes, we have 2 additional telescopes, which we call the survey telescopes, and those are used, in fact, to really take photographs of huge chunks of the sky. We have VST, which is doing that by observing the sky in the visible, so the same way as the eye does. And we have VISTA, which is taking these huge photographs in the infrared. So together, all the telescopes here in parallel really creates a formidable armada to do astrophysics. And that's really the power of parallel.
So just to clarify this for our viewers, we just saw a little time lapse of the platform and of the 4 telescopes on the platform. Just to clarify this, you're sitting in the control room, and that control room is not actually connected to the telescopes, right? You're sitting in a separate building.
Exactly. We are in fact below the platform, so that the control building will not create any interference, will not create turbulence that would in fact degrade the quality of the observations. So we are below, we are at about 100 meters from the telescopes, and everything is done remotely from here. So we can access the telescopes either by going through the platform or by going through some tunnels as well. And everything is done indeed from the control room through computers.
So I just want to come back for a minute to the target that you're observing, the Thor's Helmet Nebula. So you mentioned this already, that the constellation in which it's in. We now have an on-screen demonstration of where it is. So can you tell me can you tell us a little bit more about what is around that nebula? The VLT observations give us a very detailed, zoomed-in view of the nebula itself, but can you tell us a little bit more about what surrounds the nebula?
Yeah, when you look at it with the VLT, it may look strange why it's called the Thor helmet, because of course you would have expected some horns around the helmet, which you cannot see because indeed we are looking here in very great detail, but of course in a smaller field of view. So if you compare this, for example, to an image like this one, that I guess you will see better.
Yeah, we have it on the screen now.
This, perfect. And then you can really see why people have given this name to this nebula, because it really looks like Thor helmet. But this image from the Digitized Sky survey show a bigger field of view, but of course with much less details than what we can do with the VLT.
So are the observations still going on? What's happening right now?
Yeah, so now we are at the 3rd exposure from this long exposure of 3 minutes. And after this one, we are going to change filter in order to see what does it look like if we look no more in hydrogen, but for example in oxygen. Will it be at different places where we will see the light? And it is really by combining those different images that astronomers can try to understand what is happening there. Because now here we can really see where is the hot hydrogen. When we will move to another filter, we will, for example, be able to see where is the very hot oxygen. And by combining all of that, we can really get a physical description of what's happening there, behind just the beauty of the object, but go to the physics of it.
And actually, just to let our viewers know, later on in the day, once the observations are complete, all the observations are going to be combined, and we will be producing the final image, and you'll get to see that later on in the day. You'll get to see the final color image that results from these very observations that are going on right now.
So this is the last long image which is taken. So this means that they will be indeed combined, and we will be able then to get rid of this gap there, and really see even more details than what you can just see there on the screen.
So
now we are going to change the filter.
Henri, so the total exposure time of the final image is going to be how much?
So in total, when you combine everything, all the filters that we have, it will be a little bit over 3 hours exposure time. When you combine all the filters that we have collected in total, it's between 3 and 4 hours of data.
Okay.
Which is a small amount, but it will be an incredible image.
Is this a typical exposure time for the VLT, or does the VLT usually stare much longer at a given target?
So normally, typically, we do observation. The typical duration of our observation at the VLT is 1 hour. So we define the observation blocks, and they are typically 1 hour duration, in fact. This is in order to guarantee that the conditions are going to remain stable during the observation, and that you don't have jumps in or degradation of the quality of the image. But of course, there are some people who are looking at very, very faint objects, so they sometimes have to integrate for 20 hours on the same patch of the sky in order to see the little amount of detail that they need. So here it is really a relatively bright object, and that's why we can get already a surprising result with such a small amount of telescope time. So now we have started short exposure in the oxygen. So we will see what is the difference between this. And so the oxygen is now going to be emitting more in the green. So we are going to associate green to this color, while before with the H-alpha we were associating to red. So by combining them, we will get then the final color image. So this is the image now that we get in O3.
There is no cause for alarm. But it probably will be.
And what we can see here, in fact, from the image, is clearly. Tu peux zoomer sur l'image, Mathieu? So what we can see clearly here on the image is that when you compare this one with the H-alpha one, the bubble itself is much brighter in O3 than it was in H-alpha, while the molecular cloud, which is there, where the new stars are being formed, does not appear so much in this light. So this is why I can already predict that this bubble here on the final color image will be mostly greenish, while the surrounding will be more reddish. And I hope I will be proven true when you finish the image this afternoon.
So Henri, I actually have a question for you from a member of the public by email. And the question is, what was the telescope observing earlier in the night?
Yeah, so as I said, at the beginning of the night, we started first with CRANES. So the other instrument which is on UT1, this high resolution spectrograph in the infrared. And I was mostly looking at the comet, trying to detect, in fact, some gas which is being ejected by this comet, and looking at very high resolution with it. And then after that, we moved, of course, to FORCE in order to take the collection of images necessary to produce the final color image.
So actually, I have a second question. Yeah, go on.
Sorry. Yeah, yesterday, in fact, because I think it's also very interesting. Yesterday, I had in the second part of the night, I had a visitor. So because, of course, sometimes we also visited, like we have today with Brigitte. He was rather surprisingly observing the moon. Yeah. So you would, of course, be thinking, why would you on Earth observe the moon with an 8-meter telescope while you can do that with your naked eye? But in fact, what he was looking was not the light coming from the moon, but it was the light reflected from the Earth onto the dark side on the moon. And he was looking at that in order to see, can we detect what do we see from the space if we had to look at the Earth? Would we be able to see that there is life on the Earth? Mm-hmm. And this is the kind of measurement he was doing yesterday, and this was really incredible. So now we are doing the final short exposure in O3, and after that we will move to longer exposure in this same filter so that we can again combine it.
So while that's reading out, maybe I can just pass on to you a second question from